We had a meeting all day on Thursday, so we only got 3 days off, but I did enjoy my 3 days off. It was kind of nice. I did not answer as many. Yeah, I kind of kept my computer off on Friday, most of Saturday. Um, had a lot of emails on Sunday, but that's okay. Having a couple days off without opening up the computer is just what Mr. Shanklin needed. All right, let's get going today. Today is going to be a little bit, we're going to be dealing with what is called implicit differentiation. So it's a little bit different than what we've been going through. Last week we talked about the chain rule. Chain rule is probably the most important derivative rule there is because you use it all the time. In this first problem, this is a multiple choice problem off an AP exam. And it says if f of x equals the square root of 2x, then f prime of 2 is equal to. All right, I want to see what you get for an answer there. So why don't you work that out and see what you get there. I know putting you on the spot so early in the class. A with a question mark. Does that mean you're not 100% sure? If I was going to do this problem, the first thing I do is I look at it and it's like, okay, I can't take the derivative of square root, so I'm just going to change it to 2x to the 1/2. Now I'm going to use the chain rule. I'm going to bring the 1/2 down, leave the middle alone, times the derivative of the middle. Now these 2's are going to cross off. So my derivative really is 1 over the square root of 2x. I'm looking for my value at 2, so I'm just going to put 2 in here. So I end up with 1 over the square root of 4, which is 1/2. I'm going to go with letter B for my answer. All right, does that make sense? Yep, that really does make a difference there. All right, second problem for today for review. We have f of x is equal to x squared minus 2x minus 1, all raised to the 2/3. Find f prime of 0. You're up again. It is off indeed. Sorry about that. So I just rewrote the problem. So I'm going to bring the 2/3 down, leave the middle alone. That would be raised to the negative 1/3 power times the derivative of the middle. Well, the derivative of this is going to be 2x minus 2. And that parenthesis is really important here. So now if I'm going to rewrite this thing so it looks a little bit nicer, I might rewrite it as 2 times 2x minus 2 all over 3. And then the third root, I'm going to write it this way, the third root of x squared minus 2x minus 1. All right. I need to find the value at 0. So I'm going to plug 0 in here. 2 times 0 is 0. 2 times negative 2, so that gives me negative 4 on top. On bottom, if I put 0 in here, 0, 0 minus 1. The third root of negative 1 is negative 1. So 3 times negative 1 is negative 3. So I'm going to go with 4/3 for an answer. All right. Got confused with the plugin. Awesome. Yeah. And usually they'll give, obviously, you know, multiple choice without calculator, they have to give you values that do turn out. So they're really basically seeing if you understand the third root of negative 1 is negative 1. A lot of kids think it's positive 1, but it is definitely negative 1. So they do test your knowledge of all different types of math in these types of problems. All right. And then now a problem like this, you're dealing with the product rule and the chain rule. So if I was going to do this problem, first thing I would do is I would rewrite this as u prime. So u is equal to x, u prime is equal to 1. V is equal to, I'm going to write it this way because I know I can't take the derivative of a radical. And then the derivative of that is going to be 1/2 2x minus 3 to the negative 1/2 times the derivative of the middle, which is just 2. So these 2's cross off. So it's just 1 over the square root of 2x minus 3. Okay, so then it's inside. So now I have 2x minus 3, the square root of that, plus outside. So that's going to be x over 2x minus 3. Oh boy. Then they kind of simplified it down because I don't see my answer there at all. So I'm going to get a common denominator, square root of 2x minus 3. Well, if I do that and I multiplied the top by the square root of 2x minus 3, that just takes care of this. So now if I add across the top, I end up with a 3x minus 3 over the square root of 2x minus 3. So that's simplifying. You'd have to know how to get the common denominator and then simplify that out. Decent problem. I like it. All right, today we are going to be talking about implicit differentiation. Implicit differentiation is basically taking the derivative with respect to x, but you're going to end up with y values in there, and that's where it causes a little bit of confusion. Implicitly defined functions are an important part of calculus. For example, let me go back here. If I wanted to, let's say I gave you a function like this, and I said, okay, I have a circle. That equation is x squared plus y squared is equal to 4, okay? And I wanted you to take the derivative of this and tell me what the slope is at, let's say 0, when x equals 0. Or find a tangent line. So I want you to find a tangent line here. Well, you should be able to do that without even having to take a derivative. But what we're going to be doing tonight is we're going to be dealing with functions like this. Now, could you rewrite this as y is equal to? You sure could. But using implicit differentiation, what that says is that you just take the derivative like normal. So the derivative of 2x is just, or I'm sorry, x squared is just 2x, plus the derivative of y squared is just 2y. But since this is, I'm taking the derivative of y, I have to put, I usually, some books teach it as dy dx. I just put y prime here, is equal to, and then 0, because I have to take the derivative of everything. So now your next step would be just to rewrite everything, get y prime by itself. So I'm going to subtract off 2x. So this gives me 2y. Y prime is equal to negative 2x. Then I'm going to divide through by 2y. So I end up with y prime is equal to negative x over y. So that's my derivative. It's kind of interesting because now I can find the slope at any given point using this. Well, you have to have, now you have to have the point, you have to have an x and a y value. So if I wanted to point here, this would really be 0, 2, isn't it? Because this is radius squared. So my x value is 0, my y value is 2, so that slope there is 0. So that's implicit differentiation. Implicit differentiation is taking a derivative with respect with that y value sitting there. And they get tougher, but they're not that bad. And the steps that we use to solve, okay, so if I asked you to take the derivatives here, this is easy. The derivative of 3x is just 3. The derivative of 3y, though, is 3y prime. You take the derivative just like it was an x, but then anytime you have a y, you have to tack on that y prime. So the derivative of 3y squared is 6y y prime. Because if I said, what's the derivative of 3x squared, you would say it's 3 or 6x. But if it's a y, then you take, it's the same derivative. So this is going to be 6y, but since it's not an x, you have to tack on the y prime there. Okay, so that's the really important thing, is to be able to take the derivative with that y in there. Now, if I gave you something like 2xy, well, now this is a product rule. I'd have to say u is equal to 2x, u prime is equal to 2, v is equal to y, v prime is equal to y prime. Inside, so that would be 2y plus outside, that would be 2x y prime. So the derivative of this is this. All right. Any questions? Because we've got one more problem down there. 4x squared y to the third. And I'd like you to try to take it. Okay, why don't you try to take the derivative of 4x squared y to the third and see what you get there. That's the reason why I should never turn off my mic, because I always forget to turn it back on. Okay, so in this problem, u is equal to 4x squared, u prime is equal to 8x, v is equal to y to the third, v prime is equal to 3y squared y prime. Inside, so I've got 8x y to the third plus outside 4x squared 3y squared y prime, and I probably could have just wrote this as 12 here if I wanted to. It would have made a lot more sense, but that's okay. So let's see here. So it looks like you had the correct answer. Very nice. Awesome. Okay, so now once you understand how to take the derivative of each term, now we're going to be taking the derivative of a function to find out what the derivative, or write an equation of a tangent line or something like that. So now, here are the directions, the steps for finding the derivative implicitly. Step 1, differentiate both sides of the equation with respect to x. Step 2, collect the terms with dy dx on one side of the equation. Factor out dy dx, solve for dy dx. Now, I don't call it dy dx. This is y prime. Y prime, y prime. Okay. I mean, you can label it as dy dx if you want to, but I just say it's y prime. So here's the first problem. It says, find the derivative of this function. Well, finding the derivative, if I wanted to rewrite it as y is equal to, this would be a really difficult problem. But using implicit differentiation, step one, it says take the derivative of every single term. Okay, so that gives me 6y y prime plus 2y prime is equal to 5. Okay, that was step one. Step two, collect all the y primes on one side. They are ready. Get rid of anything else. Well, I've got two terms on the left-hand side that have y prime. Step three, factor out a y prime. Y prime. So this gives me 6y plus 2 is equal to 5. Now I want to get y prime by itself, so I'm going to divide through by 6y plus 2 on both sides. So my derivative of this function is 5 over 6y plus 2. That is the derivative using implicit differentiation. All right, let's try another one. This is one. Okay, it's kind of a good problem. Off an AP test, multiple choice. I'd like you to work it out, see what you get for an answer. Okay, and if you can get this one, you're good. I mean, you know implicit differentiation. All right, so I'm going to turn off my mic. I'll try to remember to turn it back on, but I will definitely give you some time to work. All right, I was just starting to write the problem on the board, so I'd have it up there. I'm not sure what the right answer is yet, but let's go through it. So we have to take the derivative of every single term. Derivative of 17 is just 0, so that's an easy one. X to the third, that's an easy one. 2y to the third, that's a pretty easy one also. That's just 6y squared y prime. 3xy, yeah, that one I have to do a little bit of work on because that's going to be the product rule. So I've got 3x, so u is equal to 3x, u prime is equal to 3, v is equal to y, v prime is equal to y prime, okay, inside, so that's going to give me 3y plus 3x y prime. Got to write real small. Boom. All right. I'm going to get every term off the side that doesn't have a y prime. So I'm going to subtract off 3x squared. I'm going to subtract off 3y. So I'm going to be left with a 3x y prime plus 6y squared y prime is equal to negative 3x squared minus 3y. Okay. So now I'm going to factor out a y prime. So that leaves me with 3x plus 6y squared is equal to negative 3x squared minus 3y. I'm going to divide through by a 3x plus 6y squared, so y prime is equal to negative 3x squared minus 3y over 3x plus 6y squared. Now, I got to simplify, so I'm going to pull out a negative 3 here. Leaves me with x squared minus y. I'm going to pull out a 3 here, so that leaves me with x plus 2y squared. Those cross off, and I'm left with just that negative sign there. So I've got a negative x squared minus y over x plus, ooh, the only thing I don't see on yours is the negative sign. I don't know if you just didn't put that in, but that is absolutely correct. You have got it. That is the majority of this week's assignment. Implicit differentiation. Okay, that is the majority of it. So you've got that taken care of. Now there's one other thing that we do have to talk about today. Oops, I guess I have another problem. I thought I had. Okay, that comes next. All right, let's try one more problem. All right, so here's one more, and then we'll go on to the second type of material for this week, and that's finding the inverse function or the derivative of an inverse function. So why don't you give this one a try, and then we will go on to the second part. But this is, I would say this is 75% of everything that you have to do tonight. Okay, so are you going to say your answer is none of these? I hate when they put that in there because I don't. Okay, well, I don't know. I haven't done the problem yet, but sometimes the answer is none of these. Okay, so let's take a look at this one. That minus sign is really going to cause some problems. I will guarantee you that. I would change it and make this negative here. Okay, just because I understand what's going to happen. So in this problem, this is just going to be 6x. This is going to be 10y. Y prime is equal to 0. Now here, I'm going to let u equal negative 2x. That's a negative 2x. U prime is equal to negative 2. V is equal to y. V prime is equal to y prime. Okay, so inside, it gives me minus 2y. Outside gives me negative 2xy prime. Okay, I'm going to keep all the y primes on one side, so I'm going to subtract 6x off. I'm going to add 2y. So this is going to end up being negative 2x y prime plus 10y y prime is equal to negative 6x plus 2y. I'm going to factor out a y prime. So that gives me negative 2x plus 10y is equal to this, and I'm just going to divide through by that. So that's negative 2x plus 10y. Going to factor out let's try a negative 2 here. So that gives me 3x minus y. And if I factor out a negative 2 here, it gives me x minus 5y. Those cross off. Okay, so do I have something 3x? Nope, that doesn't work. Let's say I pull out a negative 1 here. So that gives me negative 3x plus y on top. And so that looks like this here. Okay. And then if I pull a negative 1 out of the bottom, I'm left with negative x plus 5y. That's this one here. And the negative 1's cross off. So I'm going to say my answer is B on that one. Kind of crazy with all the negative signs there. You just have to be really careful with those negative signs. Yeah, and that'll cause some problems. All right. Now we're going to talk about inverse functions. If I gave you a function like this, if I said y is equal to x squared, and I said, okay, I'm going to plug 2 in there. If I plug 2 in there, I get 4 out. What can you tell me about the inverse function? Anything about an inverse function? It has a 0.42, right? An inverse function takes the function and it just flips it. You know, if you plug in 2 for x and you get 4 out for y, then if you plug 4 in for x, you'd get 2 out for y. And you know, I can figure it out because the inverse function of x squared is just the square root of x. So if I put 4 in here, I get 2 out. Now, the inverse function does not let you, this formula only lets you find a value of an inverse function's derivative. Okay, that's all it does. It doesn't let us find the inverse function's derivative because that would be really hard to do. So in this problem, I could actually find the inverse is derivative at any point because I could take the derivative here. The derivative of this would just be, so that's x to the 1/2, so that'd just be 1/2 x to the negative 1/2, so that would be, so the derivative of the inverse function is just 1 over 2 the square root of x. So if I plug 4 in here, the square root of 4 is 2 times, so that gives me 1/4. Okay, so I could find it. Now, most of the times you can't find the inverse function. That's why they have this little formula. So now let's see if I can get the same answer of 1/4 by using this formula. Well, this formula just says that it's just 1 over the derivative of f inverse of a. Well, in this problem, my value, f inverse, is 4. So, because when I plug in 4, I get 2. So if I put 4 in here, f inverse of 4 is 2. So f prime of 2, so this is just be 1 over f prime of 2. Well, now I have to take the derivative of this, because that's my f function. So that would be 2x. If I put 2 in there, 2 times 2 is 4. Oh, I end up with 1/4 also. So the formula does work, but it's just 1 over the derivative of the inverse's value. That's it. But all we're doing is we're just finding the slope of the inverse function. All right, so here's talks through it a little bit more. So here's an example of a problem. It says find the equation of a tangent line to the inverse at the given point. I think this problem's on our assessment this week. So if you plug 1 in here, okay, so f of 1 is equal to 1 plus 7 plus 2. So f of 1 is equal to 10. So my ordered pair would be 1, 10. So the inverse would be 10, 1, right? So if I was going to find this, if I wanted to find the slope of the inverse of this, well, finding the inverse of this function would be awfully difficult. I don't know if you remember how to find the inverse function of a function, but the rule that I used to teach when I was teaching algebra 2 is that in order to find an inverse function, you flip-flop the x and y's around. So you would rewrite this as x equals y to the third plus 7y plus 2, and then you solve for y. Oh, no, this would not be an easy function to solve for y. Not in the least. So trying to find the inverse function of this thing would be difficult, to say the least. So that's why they come up with this cool little formula. Okay, so now all I have to do is find the inverse or the derivative of the inverse of 10. Well, we know that the value is going to be 1. So now all I need to do is find the derivative of this function and plug in 1. So the derivative of that function is 3x squared plus 7x. Plug in 1 there. So that's 3 plus 7, that's 10. So my slope of the derivative, where did the 1 come from? They gave us that value in the beginning. They gave us this here. So I knew that if I plugged 1 into the original function, I better get 10 out, because an inverse function is the ordered pair is just flipped. So I just plugged 1 in here and I came up with 10. So that kind of solidifies that this is the point that we were using. So it's just my x value is 1, my y value is 10. Now when you do the inverse, if I plug in 10, I should get 1 out, right? And that's why you need this piece of information. If you don't have this piece of information, there's no way to do this problem, because we need to know what the inverse function is equal to. And there's no way I could write an inverse function for this. I mean, it would take me a long time. Why is f inverse of 10 equal to 1? Because, don't you remember an inverse function? If I gave you, let's go back a page, 2 pages. So here, if this is my function, okay, let's call it f of x. It doesn't matter what we call it. Let's call it f of x. So f of x equals x squared. What is f of 2 equal to? Well, f of 2 is equal to 4, right? So that means when I plug 2 into my function, I get 4 out. That's my point. So now I know that this is a point on the inverse function, correct? Because when you flip an inverse function, all it does is it flips the x and the y values around. So this is a value on the inverse function. And I need that because if I don't know that, if I plug 4 into the inverse function and I get 2 out, I can't use this formula. But we know that because I took a function that we knew all the different pieces of it. I knew that the inverse function is the square root of x. So if I plug 4 in here, I do get 2 out. It's just, so the formula is just, the formula is just, it's like if I gave you something like this, let's use, okay, let me get rid of this. If I gave you, if I said, okay, f of x equals, no, I better do something like this. Let's say I said f of 2 is equal to 4, and then I said g of 4 is equal to, it's equal to 2, okay? So that's basically what this is down here. This is a composite function. You have to solve this first. So you have to figure out what f prime of a is equal to. So it's just, so you just have to figure that out. So in this problem, g of 4 is 2. So in place of g of 4, we would just put 2 there. And then you would say, okay, now I'm going to plug 2 into the f function. Well, f of 2 is equal to 4, so my answer would be 4. That's basically what they're doing with this function. It's like a composite function. You got to figure this out, and that'll give you a value, and then you plug that into the derivative of f. So you're going to have to find the derivative of f to use this function. So if I go back to this problem, oh, I'm going the wrong direction. Sorry about that. Okay, so if I went back to this problem, I know, because the formula is 1 over f prime of the inverse. Okay, that's what it's saying. So I know I need the derivative. Okay, so f prime is equal to 3x squared plus 7, right? So I know I need that. And I also need this. I need the point, the inverse value, because if I plug in 10 here, so I'm going to go the derivative of the inverse of 10. Well, what is the derivative, or I'm sorry, not the derivative. I always get those mixed up. What is the inverse of 10? What is the value? 1. Right. So in place of all of this, I'm just going to rewrite it as 1 over f prime, or the derivative of 1. So now I just have 1 over, so I know 1 is going to be on top. So this is telling me plug 1 into the derivative of f. Well, the derivative of f is just 3x squared plus 7. So I'm going to plug 1 in here. So 1 squared is 1. 3 times 1 is 3, plus 7 is 10. And so this would be the slope of the inverse function at that point. That's all it's giving us. Oh, sorry about that. Sorry that I did not explain it well, but that's it. That's all you have to do. And I believe I think this is the only problem on the assessment that deals with an inverse function. It's not used a lot. I mean, it is, you rarely will ever see this, but I have seen it on a multiple choice test, and the kids are like, Mr. Shriven, you didn't show us inverse functions, how to find the slope of an inverse function. And it's like, oh, okay. So I thought I'd better show the formula. I mean, it's an interesting one. I mean, but I mean, the majority of this week is implicit differentiation. That is the majority of this week. All right, that was my last slide. Any other questions? All right, have a great week. Try to stay warm. It's getting a little bit colder outside. Hey, do I have your sister in Algebra 2? Because you guys have because you guys have a very unique last name. Yeah. All right. She's a very smart young lady. I think she ended up with the highest MAP score of all the kids that I have. Yeah, she's pretty good. Yep, math must run in your family. She must take after her older sister, right? All right. We will see you next week, same place, same time. Have a great week. Bye.